Hello and welcome to the UberCloud webinar, Power of Cloud for Engineering Applications. Today we're going to talk about how you can run OpenFOAM, the open source CFD toolbox, on Microsoft Azure and create a very flexible engineering environment for yourself in just a few minutes. As you might all know, the OpenFOAM CFD toolbox is a very flexible environment already, open in its nature. We have customers who have been developing anything from fire simulations to looking at the blood flow in people's veins to looking at water flow around the hull of a ship. So the implications and the areas where OpenFOAM can be used are just about endless. And similarly, Microsoft's Azure infrastructure is quite flexible. It can give you access to a remote server in more than 10 different geographies around the world. And with just about any size of compute power you're looking to get your hands on. So we think that putting the two together is a very interesting toolkit for engineers like us. So we'll get into that today. We're going to be hands-on. We're going to be looking at how you can do all of this on your own on Microsoft Azure. So let's get started. Briefly about UberCloud. We started UberCloud back in 2012. It was started by myself and Wolfgang Gensch, my partner. We currently have offices in California and Germany. And since we started, we've been very fortunate and we have received a number of awards. This year, we've been selected Cool Vendor by Gartner. And for the last 2 years, we have been the best in HPC in the cloud winner by HPC Wire. UberCloud enables companies to consume compute-intensive applications as a service. We believe that engineers shouldn't have to worry about the piping, meaning what kind of infrastructure am I running on, what kind of operating system even is underneath, where is the server, who set it up for me. What we should care about is, can we run our applications the way that they're intended to, similar to running them on our desktop computers, however, with a lot more compute power whenever we need that compute power. So at UberCloud, we develop solutions for engineers to get on-demand, high performance, and easy to use access to more compute power. Since we launched the company, we have been, again, very fortunate to be joined by a number of sponsors, partners, and paying customers. A few of them are definitely worth mentioning. These are Intel, Ansys, Autodesk, Microsoft, Amazon Web Services. We couldn't have done what we're doing here without their help, support. So a big thank you for all our sponsors, partners, and customers. So let's get a little more focused here. Microsoft Azure is the name of the infrastructure as a service offering from Microsoft. The data center infrastructure of Microsoft has been developed over a number of decades, and currently they have more than 100 data centers around the world, and the Azure service sits right on top of that. So with Azure, you have the ability to specify what kind of compute power you need and which region of the world that you would like that compute power to be made available to you, and Azure will get that running for you, and you can manage all of that through a control panel, which we will play with in just a second here. So when you put this kind of a flexible infrastructure in front of engineers, if you can make it very easy to use for specific engineering use cases, they can do very interesting things with it. So we will look at how this is all going to work out in just a second. Briefly, again, very high level, about the technology that runs underneath all this. So on the left-hand side is a typical hypervisor type of deployment. where there's a host operating system layered on top with a hypervisor, and on top of the hypervisor sits a number of guest operating systems. This is the traditional, let's say, virtual machine-based world that we've been living in for a number of years now. On the right-hand side is the way which UberCloud is building applications. As you can see, there is no hypervisor. There are instead Linux containers. And in this kind of a scenario, the containers are isolated from each other, but they share the host operating system components, like the Linux kernel, for example, which is the largest portion of the operating system there. And the applications sit on top of that directly. There's no hypervisor in between, giving us a much faster deployment cycle, very, very low overhead, and much easier migrations for us. So that's the underlying technology. You can read more about it on your own. If you have further questions about how this works, I will be very happy to talk further about it. Okay, so let's get a little more specific again. Let's talk about how we will run OpenFOAM on Azure. We will be looking at a few key differentiating items here. We all know you can pick up some kind of a cloud server. You could find the binaries of OpenFOAM. You could somehow download them. If necessary, you may need to compile certain portions of the application, and you could get OpenFOAM running. However, there are very important aspects to get it to work in a very effective way for you. So one of those is pre and post processing. We need to make sure that in the cloud it works the same way it would work on your desktop. So keep your eyes open. I will demonstrate that. The automated monitoring capabilities need to keep you in control when you are connected, and even when you're not connected to this cloud server, because it's not a desktop anymore, and having control over it is a little more difficult than you normally would go through. And also, the real power of the cloud in this case comes to light when you work on more complex simulations where parallel processing is required. So your desktop may have, let's say, 2 CPU cores, maybe 4, and we are going to look at how you can have multiples of that on Microsoft Azure for your larger simulations where you don't have enough CPU and enough memory on your local system to run it. So keep your eyes open for those. I'm now going to jump out of slide mode, and I'm going to take you through a live demonstration. So at this point, let me see if there are any questions from the group. If you have a question, you can use the GoToWebinar control panel to your right and type in your question, please. Okay, in the meantime, I'm going to get set up. Okay, great. So we are going to look a lot more in depth. However, this is the Microsoft Azure start board. I'm going to show you how to make this work. I started a server here, PT1019. I'm going to show you how to do all of that, so don't worry about it. And now let me show you what happens when that is started. So we're kind of starting from the end, and we'll get back and show you how to do it on your own. So when you create a new instance on Microsoft Azure with UberCloud's OpenFOAM solution on it, what you will see is an email that looks just like this. And I'm going to copy this password here. There's a launch button made available to me. I click on that. I'm not installing anything, as you can see. The link just launched a new browser tab, and this is a remote desktop connection to the machine that I just launched. Here we go. So let me maximize it so you can see better. The background you see here is a dashboard, or actually a desktop, I should say, a desktop of the machine that I just launched on Microsoft Azure. Okay, it's a full desktop view. Let's increase the resolution a little bit here. There we go. Give ourselves a little more room to work. And in this environment, let me show you a few things. Let's move this OpenFOAM window here. For example, for the ones who are already familiar, you can see that OpenFOAM is pre-installed, ready to run. Obviously, I didn't pass in any sort of input file, so it will error out. I think I have a question from someone here. Looks like the screen was frozen, so I just restarted that. Hopefully that will work. If the screen is still frozen, please let me know. So I just got on the desktop view and I was showing what it looks like. Here we are remotely connected to the Azure server. We are seeing a remote desktop connection, and I was showing that if you open up a terminal there, you can just take a look at OpenFOAM being pre-installed. So I didn't have to install anything to make this happen. I'm going to show you how I got to this point in just a second. You will do it on your own computer as well. So the other interesting thing is we have full desktop capabilities. So there's just there's a file manager that you could go through your files. So it really feels like a desktop computer is what I'm trying to get to. We even packaged applications such as an Office suite, so that when you're writing a report to your management, you can just do it here on the remote desktop computer. The other important thing is I just typed LSCPU. You have full access to all the power of this instance. So this way you could run larger simulations. 8 CPUs is not huge. I'm going to show you what other types of compute power we can get our hands on. And there's a README file on the desktop which tells you where things are installed. It tells you about a few commands which you could get more information from the environment on, so on and so forth. So the last thing I'm going to show you very briefly is the ParaView viewer. As you know, this is the pre- and post-processing environment for OpenFOAM. As you can see, it's already pre-installed, and you can look at 3D objects. We are going to do this in a lot more detail in just a second. I just wanted to show you that it's there. So these are the capabilities in a nutshell. So parallel processing environment pre-set up for you. You don't have to install anything. You can launch a box. You can define what kind of box you would like to launch, what kind of CPU, memory, disk that you would need access to. And UberCloud will simply create that on Microsoft Azure and launch it for you. Okay, let's see if there are any other questions from the group. If not, I'm going to stop here and I'm going to show you how to do all of this on your own. Then we are going to look at, on the new environment we launch, we are going to look at what kind of prepackaged examples we have access to. We are going to look at how we can do meshing. We are going to look at what kind of automation tools are available here. So here's the time when we will get a lot more in depth as to what you can achieve with this application. All right, so if there are no other questions, I'm going to now go all the way back, go back to Microsoft Azure. The first screen of Microsoft Azure looks just like this. And I'm going to start walking you through a series of steps. I understand that you may get lost during this, and that's okay. I'm going to show you a link. I'm going to actually send it to you so that you can easily get help. So on this page, we have provided a step-by-step guide. I'm going to send this link to you now. You will receive it through GoToWebinar. Here we go. It's coming to you through the chat window. Okay, so it's there. And you can click this link right here, and it will open up a PDF page. On this PDF document, you are going to see step-by-step everything I will do starting now. So you can easily do this on your own. You can show your colleagues on how to do this. So it's a good way to keep track of what I'm doing. So the first step in that is registering for Microsoft Azure. I'm not going to walk you through step by step on that, but it's all here, and I will assume that you already have a Microsoft Azure account and you can follow me. Again, if not, you can always catch up later. So once you have a Microsoft Azure account, this is the first page you would go when you log in. Now, as you would expect from an infrastructure as a service vendor, Azure is offering you a bunch of, let's say, services. We call them primitives sometimes. These services can be put together to launch any sort of compute environment you would like. So you could create virtual machines, you could put them on a public IP address, you could tie them with each other using network interfaces, you could add storage behind it, and you could create a compute environment that would run the task that you want it to run. The one thing to remember is, first of all, you would need to know how to assemble all of that, and number two, you would need to know how to put OpenFOAM on that and configure it for yourselves. So what we believe in at UberCloud is that a mechanical engineer shouldn't have to worry about any of that, and it should be prepackaged. So we created, I will click on this new tab right here, a fully integrated solution into the Azure Marketplace. So I clicked on Azure Marketplace. Azure Marketplace is a place where packaged offers are made available on top of Microsoft Azure. So let's type OpenFOAM because that's what we're interested in. Here I see two offers because UberCloud is the developer and I can see the new upcoming staged version. You would see only one. So just pick that. Here it tells you a little bit more about which software applications are involved. So I'm ruining the surprise here. We are going to look at Salome, GMSH, CFMesh together. So let's say create. Now notice here how you really don't need to have any IT expertise. It's asking for a server name. Let's just give it one. I like to use names that I can easily remember. 1019. Okay. It will ask for a username and password. This username and password will be put in there for administrative purposes. You are not going to need it, but just in case you do, note it somewhere. The resource group name can be anything. I like to name it the same as the server name, except I add an RG at the end of it. This part is important, the location. So as you can see, these are all the various locations that Azure service is offered in. This is great because the closer the machine is to you, the more fluid the remote desktop interactions will be. So please keep in mind, pick a server that is as close to you as possible. I'm in Silicon Valley, so I pick Western US. I say OK. Now, as a next step, it's going to ask me, okay, I'm going to create an environment for you. What kind of compute power do you need behind it? So here it's showing us 3, but there's a nice little button here. It says view all. Let's click on that. So now we can see all the different, it just keeps on and on and on. It's showing us all the different kinds of compute power we can create on Azure. I'm going to pick one that's, let's say 16 would be good. The list is so long. Oh, it looks like there might be a shortage of the 16 cores for some reason as this training is going on. Let me click on size again. Maybe that will help. Say OK again. There we go. I don't run into that problem very often. That's interesting. So I guess I will have to settle for 16 cores for now, or I mean 8 cores for now. Yep, the 16s are not available for some reason. Okay, so let's go pick an 8-core machine. Now, I clicked on this one right here. I can see that it got selected. So I'm getting 8 CPU cores, 28 gigs of RAM. So these three together, they go together. All right, so 16 data disks, which have IOs per second at the rate of 25,600. Obviously, the bigger this number is, the faster you can read and write from disk. And my machine will have 56 gigs of local SSD. So load balancing is not important to you. Auto scale is not important to you, so ignore those. Premium disk support is what this local SSD is all about. So submit, and it's going to show me a summary. As you can see, everything is automatically getting filled out. I didn't have to worry about networks and subnets and IP addresses and security groups, all of that. This got figured out by UberCloud's template in the background. So just say OK. It gives you a summary. Say OK. So all of this is getting pre-populated for me, and I just click on Buy to launch it. As you can see, I didn't have to do any special installations. I didn't have to worry about, let's say, operating systems and packages and RPMs and whatnot. All I do is pick a name and select the size. Okay, so I went through that pretty fast, so I didn't talk about pricing, how pricing is figured out. So let me give you a quick demonstration on that so you know how to explain it to your manager if you need to. Let's go to azure.com. You may want to take a note on this because there's a really neat page here to talk about pricing. So I just went to azure.com. I'm scrolling to the bottom, Marketplace. You don't need an account to look at this page. So that's another reason why it's very nice. Search for OpenFOAM. Find the UberCloud offer. Okay, so you see the same details as I showed you as I was purchasing this offer. Scroll down and you'll see all those different instance types again. Okay, now take a look. Obviously, the more cores, the more compute power. That's not the only thing that increases by cores, obviously. When you request a server that's, for example, an A4, that has more memory than an A0, it has more CPU cores available than an A0. So as you go down, the compute power is increasing. By the way, there are quite a bit more down below. I'm just showing you the first 5. Now look at the price columns. There are 3 columns. On the left-hand side is the price of the compute server only. So this is what Azure charges for the CPU power, the RAM, so on and so forth. So this is just the compute power. The second column is the software price. That's what UberCloud charges to make all of this bundled and ready to work in your environment. So that's the software price. As you can see, it's 14 cents per hour, and below 4 CPU cores, it's free. So come in, experiment with it, play around with the environment. We don't charge anything, and we believe in you being able to select as large of a compute power as you would wish. So for example, if I was to go down, here's a 32 core machine and it's still 14 cents an hour. If you're wondering, if you kept this environment running 7/24 all day, all night for a full month, that would cost you about $100. So then the third column is just the total price. So the sum of those two columns. So now you have a good understanding on how the pricing works. Let's look at a G5 here, for example. This is a pretty powerful machine. It's a dedicated environment with 32 CPU cores. It comes with 450 gigs of RAM, or very close to it, maybe 440. So we can really work with, our more detailed models. We can simulate at a system level rather than in terms of smaller components. We don't have to really worry about our mesh sizes. They can be fairly large. So this environment would have a very good chance of handling your larger simulations. And you would only be paying for the time that the server is running. If you turn it off, then you're not paying for anything. The prices here are quoted as per hour. However, Azure actually charges by the minute. So if you run it for half an hour and you shut it off, you'll only pay half of that. So pretty flexible environment, and we'll now see how it all comes together. Let me close this. So in this document, I just walk you through step 2. Now I'm going to take you into step 3. How do you run the UberCloud offer? So when the environment that you ordered is in the process of launching, you will see it spinning around like this. And in the notifications, you will also see that the deployment has started. You can also see all the previous history here in notifications. I like this notifications area a lot because it's just a quick way to see what is going on in my environment. So deploying a new instance takes anywhere from 3 to maybe 6-7 minutes sometimes. Depends on the type of instance you selected. Obviously depends on what else is going on in the infrastructure at that point of time. So my experience is that's between 3 to maybe 6-7 minutes, somewhere in that range. And once this is done, what you get is the environment is built for you. It has the operating system pre-set up. It has the UberCloud OpenFOAM offer already built on top of it. So at that point, there's really, let's say, no administrative work that you would have to do. So once this is complete, then it looks exactly like this. I launched this one literally a minute before our session started here. So let this guy spin. We'll look at it when it's done. But here's what that will look like when it's complete. If there's one thing that's kind of hard to remember, this is the point. So when your instance launches, you will see a public IP address right there. And I would need you to copy that, bring it here to a new browser, and connect to it. I mean, if there's anything you need to do as an extra effort, that is the part. And since I already started this, it knows my email address, so it launched everything. But when you launch it for the first time, it would ask for your email address. So that's all there is to it. When you enter your email address, you get this email, and you can connect to your environment. That's it. There's really no other magic. It's starting to get boring, I know. Okay, so let's jump into the OpenFOAM environment again, and let's get into a lot more details about what you can do with this environment. So I already shared with you that the terminal is right there. Since OpenFOAM is a terminal-based application, you really don't need to open a remote desktop and connect to the terminal. UberCloud gives you full access to SSH. So normally what I do is I copy that. We even give you the SSH command, as you can see. I enter that and the password. Now I'm connected to that environment. This might be a little too small for you to see. Let me enlarge it a little. So now I'm connected to Microsoft Azure. Let me clear my screen. There it is. So what I just did is, instead of going through remote desktop and working in a terminal that's sitting on a remote desktop computer, I'm now connected directly from my machine, and I'm doing SSH. So obviously, if you have this capability, what else can you do? You can also use SCP. I could transfer files to this environment. Again, we give you the command. You would just change it. I thought I would have something that's named Rock, right? Okay, I see I have a PNG file here. And that's it. So the file copy from my desktop directly to the Azure server that was set up for me. This is getting easy, right, guys? So that's one way to transfer files. I'm going to show you a bunch of other methods. Here you go. Data transfer tab. If you're a user of a cloud storage solution, like for example Dropbox, here's another way you can bring your files in. This happens to be my favorite method. My personal email address. Go. All right. Second time I typed it correctly. Let's go into advanced settings. You don't want to see my Thanksgiving pictures, so let's get rid of that. You don't need that. We don't need that. Okay, fine. So now my Macintosh computer, my desktop, is connected to my Microsoft Azure server, and now the two are getting, let's say, synced with one another. And you'd be pleasantly surprised as to how fast this can transfer your files back and forth. And remember that this is a sync. So if I was to add a file here, it will magically show up on my desktop computer. If I add something on my desktop computer to my Dropbox folder, it will magically show up here. So I don't have to keep managing files back and forth. Okay, so there are a number of files in that Dropbox directory that are interesting to me now. Let's start looking at a few examples. So for example, I will show you. Let's do, okay, I see T3 MSH, great. So let me show you Salome, first of all. So Salome is the CAD environment, one of the CAD environments that we are providing to you out of the box. So with Salome, I will now open an angle bracket file. Let's take a look. Load script. It's on the Dropbox angle bracket. So what's going to happen now is Salome is going to open that CAD geometry file for me, and I'm going to show you that you can in 3D look at that CAD file. Now, obviously, the goal is not to replace your desktop computer here. The goal here is, just in case you need to see your file or your CAD, you should be able to. So you shouldn't have to keep going between your desktop computer and your cloud server here, you should be able to just that went really fast. There we go. There's our file, and you can already see that this is pretty fluid. Remember, I'm on a remote desktop connection. I'm displaying this on my screen, and you are on a webinar session, seeing the remote desktop of a remote desktop. So if this is jumping around a little bit on your desktop, that's okay. As you can see, I can look at my 3D geometry right there in the cloud. Okay, so that's the idea. We give you this capability so you can look at your CAD files if you need to. You wouldn't throw away your desktop computer, obviously, but this is so that you don't have to keep copying things back and forth all the time and worrying about. Yeah, can I see this? Can I take a look at this? All right, and if you needed to make a minor change, you could still do that here. Okay, so let's get rid of that. Now, let's go one step further, and I'm going to look at let's do it this way. Now looking at the GMSH tool, again, a different CAD geometry. I can manipulate in 3D. The cool thing about GMSH is it also has a mesher. All right, I just meshed that, and now I can see that mesh in 3D. So now we're at the second step of a flow, right? We could look at CAD, we can do meshing. We also have another mesher here. Let's look at CF mesh. Let's do it this way. Here's an interesting thing at this point. I configured CF mesh so it will take on all of the CPU cores. So you may have not noticed, but at the top here, which was a black rectangle, is actually the resource manager. So let's take a look. There it is. We can see all of our cores. This machine has 8. All CPU cores are pegged 100%. They're all working on meshing that geometry for me. So the reason I came here is to talk about our monitoring capability. When you have a long-running job, you wouldn't sit down and wait in front of this computer for hours at end. What I would do in that kind of a situation is I would leave the resource monitor on one side of the screen and my standard out on the other side. So for example, if this was OpenFOAM, it would continuously be printing my convergence related information. So that's the screen I would leave. I would simply close this. It's still running. I just happened to close the remote desktop connection. It will continue to run, and every 6 hours it's going to send you an email, and in that email it's going to send you screenshots. So in that screenshot you will be able to see your resource monitor. The screenshot will look very similar to what you see here. Obviously it's full size, and in that screenshot you can see your resource monitor and your convergence. And if you need to go back and take a look, let's say because it's not converging or you're running out of memory, you can always log back in, and you will see that the desktop stays the way you left it, and your processes are continuing in the back. So very important to note, Closing the remote desktop doesn't stop the billing, it doesn't stop the server, everything continues to run in the background. It just means you're not looking at it anymore. So let's let this meshing operation continue, and once the mesh is done, I'm going to just launch ParaView. So now we will be able to see what that mesh looks like inside of ParaView. So here you can see my CAD, my measures, my visualization tools, my solvers. Everything is nicely packaged, neatly made available to me, and I can work on it just like it was my desktop computer. And the other nice thing is I could launch more than one of these if I wanted to. And let's say if I wanted to run the same simulation with 2 different sets of parameters, I could do that. Now what do I get? I get double performance, right? The other cool thing is when this is all running, there's no load on my personal computer. So you may have noticed many times when you're running something on your desktop computer, like a simulation is running, then everything else is just so painfully slow you can't even check your emails. So I don't have that problem here. Let's see if there are any questions from the group as this is running. I don't see any, so let's continue here. Okay, so now the meshing has completed. It's just doing the check mesh, and as soon as that's done, let me just run it on ParaView so we can look at what this mesh was all about. It's quite a bit more complex than the few previous ones that I looked at. The first one was an angle bracket. The second one was like a duct, and now the titles are giving it away. It is actually the hull of a ship. Okay, so it's opening it up. Takes a few seconds, even on a more powerful computer like this. Okay, here it is. Let me open it up in points, so it's a little bit easier to see. Let me zoom in. Alright, so as you can see, hull of a ship. Let's rotate it a bit. And there it is, the front of the ship, the back of the ship. From a different angle. You get the point. So again, the idea is you wouldn't throw away your desktop computer for CAD work. You wouldn't throw away your desktop computer for doing the visualization. However, it's all here as well, all pre-integrated, ready for you to use, so that, for example, if you're doing a set of parameter studies, you could come here, you can look at your results, and for example, you would only download the results which make sense to you. So let's say a few of your runs were just experimentational in nature, you looked at them through ParaView, you looked at the flow lines, etc., and you just think, oh god, okay, so this didn't work right. You don't even have to copy those back. And if you need to make a few changes to your CAD geometry and run it again, it's quite easy to do as well. That's the idea. Okay, so another quick point here. We packaged a number of examples right here on the desktop. You can see that we have a full-featured browser as well, so let me just point out to that. So the tutorials are pre-packaged as well. So let me go back. to my home directory, and this is an easy and fun way for you to get familiar with the environment. I'm just making a copy of the tutorials, and I'm going to run the cavity flow example. The steps that you need to follow are simply in these boxes, so you can just simply copy paste them. There we go. So let's run the mesher that comes prepackaged with OpenFOAM block mesh. Done. Obviously, it's not a very complex geometry. As you can now see, ParaView and OpenFOAM are nicely knitted together as well. There you go. Let's also put it in a wireframe. There it is, all meshed, ready to go, ready to solve. So I just wanted to show you a number of examples how you can go from CAD into meshing into solving. So now let's briefly talk about the volatile disk. Sitting right here on the desktop, double click it. It has a nice little warning message. The idea is we gave you two types of storage. By default, your HPC user home is linked to long-term storage. If you shut down this box, bring it up in let's say a month, all your files on HPC user directory will still be there. However, we wanted to also give you a much faster I/O read-write capability, and that's what the volatile disk is all about. The volatile disk is sitting directly on the same server that's launched for you, and it gives you additional horsepower in terms of I/O reads and writes. So for your simulations that hit the disk a lot during the run, you could use the volatile disk as a scratch space. Read and write to it. It will help the performance of your simulation run. However, when you're done, you'll need to remember to pull your files from volatile into your HPC user home. So volatile disk, remember, it's a scratch space. When you restart the environment, there's no guarantee that your data will still be there. It may or may not be. So pick up from volatile, put it into HPC user when you want to store that solution. What I usually do is I use the volatile disk. When I'm done, I put it into my Dropbox directory, so I can just see it on my desktop computer. Okay, that's another neat trick. Now let's take a look briefly at how we would monitor and manage this environment from the Azure console. By the way, let me briefly show you that I'm skipping to the next section. We talked about tutorials. I showed you these various examples. And now I'm going to show you this management phase, which is step number 5. So here you can see on the Microsoft Azure console, when I was doing the heavy meshing with all CPU cores, the monitor here detected that my CPU utilization spiked. So just like you could see your CPU utilization through the resource monitor that we gave you access to, you can also see it on the Microsoft Azure console. Now, let's talk about those buttons at the top here. If you needed, let's say you had runaway processes, zombies, etc. The one way you could fix that is through the restart capability here. It's very similar to powering down the machine and powering it back up. Remember the volatile disk, guys. When you do restart, the volatile disk may not survive that, so you would need to copy your files away from it. However, the restart works just the same way it works on your desktop. Hit the restart, it will start the machine again, all your processes will be cleaned out, and you can start from scratch. Your data in HPC user directory will survive. Now, the second step of that could be, let's say I did my simulation runs, I'm done for the week, I'm going home for the weekend. I would just hit the stop button, say yes. That will shut down the environment. I will no longer pay for the 8 CPU cores that I was paying for. All right, so that's the idea of the stop operation. Again, my volatile disk contents will be getting deleted. However, everything HPC user will survive. Now there's another option here, which is called delete, right there. And there's an important difference between stop and delete. So when I use stop, I'm still paying for the storage of my files. When I say delete, what I'm telling Azure to do is delete all my files securely and safely. They're all gone. So I will not be paying anything. So I'm not going to pay for the compute resources, and I'm not going to pay for storage either. So if I'm not going to use the environment for a month, this would be a good way to shut down the environment. There's another advantage to using delete, and that is when I want to launch OpenFOAM again, I will be picking up the newest version that UberCloud has placed on the marketplace, so that if I have performance enhancements, I will get those. If there are bug fixes, if there are operating system updates, all of those will be made available automatically. So what I'm trying to tell you is you don't need to maintain this environment. So when you're done, delete it. Next time you need it, launch a brand new one, and you'll get an updated version. So that's another very neat feature of using the UberCloud version of OpenFOAM. Okay, so let me see if you guys have any questions. By the way, we launched this trainer environment together. We don't need this anymore, so I'm just going to use the delete. That's it. So that's how you get rid of an environment that you had running, and as soon as I hit that and it turns deleting, I'm no longer paying for that environment. And again, the charges go by the minute, as you might recall. Are there any other questions from the group? Let's see. Now, let me take you here. I told you about the step-by-step guide, and I also sent that through the chat window on GoToWebinar. The link is also here. But I want to give you also my personal email address. So I'm available. I would love to talk to you on a free one-on-one session. If you have specific questions about, for example, how do I do a certain type of mesh? How do I add a new product service into this? Oh, I don't use OpenFOAM, I use another CAE product. How does that work? Hey, I need more compute power than Azure is offering through one of its VMs. What do I do? So if you have those type of specific questions, let's get on a one-on-one session. I'd be very happy to talk to you and give you further details about our various offers. And there's a lot more going on in our lab. So these are, today I showed you the production version, the generally available version, and we have a lot more going on, more advanced options in our lab. We also do a lot of customer-based development. So many of the features you saw today, for example, GMSH, was added to the service with one of our customers' requests. So if there are things you want to see here and they don't seem to be there, just let's just schedule a session and I'll be happy to walk you through it. Are there any other questions from the group? All right, so anyway, my email is right here. If you think of any other questions, please send me an email. We'll talk further. And I really appreciate you attending this session. My goal is to train as many mechanical engineers as possible on this feature. So please make sure to tell your friends about it. There's a session just about every week. And I'll be happy to show them the way around Microsoft Azure and how they can launch OpenFOAM on top of it. By the way, soon we're going to be adding other CAE products to the Azure Marketplace as well. So I'll make sure that I send an email back to you guys and invite you to those sessions as well. So thanks for attending. I really appreciate you taking the time, and I hope to talk to you fairly soon. Thank you very much. You have a great day.